So check this out. I'm going to show you the difference between a composite number and a prime number, and we're going to use this information to figure out how to write the prime factorization of numbers, because prime factorization means you need to know what's a prime number and what's a composite. So that's why I'm going to show you those two notes first. One thing you have to know as a side note is you have to know what natural numbers are. So natural numbers. Natural numbers are pretty much what you learn to count with when you're a little kid, right? Numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9. So keep going on forever and ever. So those are natural numbers. So when I refer to the factors in this problem, you're going to hear me say the factors. Well, we got to think of the numbers in this list here. 1 and so on and so forth. And when we're talking about composite numbers have factors other than 1 and itself. So composite numbers have factors other than 1 in itself. And when I say factors, I'm talking about the numbers in this list here, so natural numbers. So we got to think of a combination of these numbers when I say the factors in either composite or prime numbers. So factors is referring to these types of numbers. And now looking at the prime numbers only, so that's important, only has factors 1 and itself. So as a reminder, when I say it only has factors, so these factors here, the factors, let me highlight that. So when I say factors in this and in this, we have to think of the numbers of the natural numbers in this list. So we're thinking of any of these combinations of numbers up to 6 and beyond. So it keeps going forever, 7, 8, 9, 10, 11. So let's just look at an example to see what do we mean by having factors other than 1 in itself. So for example, a composite number will be something like 6. Here's why. The factors of 6 are 1 times 6. So again, remember, these numbers that we're using here come from the list of natural numbers. So what combination of these numbers, when I multiply them, gives me 6? Well, 1 and 6 is one combination. But there's another combination of numbers that work too. 6 could also be written as the factors of 2 times 3. So 2 times 3. So notice, when I went back, when I was talking about here that it has factors other than 1 in itself, so the 1 is talking about this factor here. The itself is talking about this part here. So 1 in itself, right? This is called the itself because we're talking about the 6 already. So since these two are numbers that are other than these two, then it makes it a composite number. Now let's look at a prime number example. So a prime number, for example, would be something like the number 5. 5 is prime. Why? Because I know 5 has the factors 1 times 5, right? 1 times 5 is 5. And if you look at that list of natural numbers, there is no other pair of numbers that when I multiply them from that list will give me 5. These are the only two that will work. So this is why it's prime, because the only factors are 1 and itself. So 1 and itself. The itself is the 5 because that's the number we're talking about in this case. Now let's look at another example. So another example of a composite number will be something like 12. So 12 I know has factors 1 and 12, right? 1 times 12 is 12. But it also has other factors. Other factors from this list of natural numbers. What other combination of numbers I could use? I could do 2 times 6. I can also do 3 times 4. So anytime you have other factors besides the number, right, 1 and itself, is a composite. So you can see we have 2 other combinations from that list of natural numbers that multiply to give me 12. Anytime that's the case, where you have more than one set of numbers, it's a composite number. Compare that to something like another example of a prime number. So let's look at the number 13. The only factors for 13 are 1 times 13, right? If you look at those lists of natural numbers, there's no other combination of numbers that I can use that when I multiply them together, I get 13. These are the only 2 that I can use from the list of natural numbers. And then let's look at another set of examples, so the last set of examples. So another composite number will be something like 15. Why? Because I know the factors of 15 are 1 in itself, but it also has factors 3 times 5. So when you have more than one pair of different sets of numbers, that gives you the same number when you multiply them together. Again, we always have to think of those numbers from that list. When you multiply them out, you get 15. You have two different pairs. So anytime you have that, more than one set of numbers, it's automatically composite number. And if you compare that one into, like, for example, the number 2, the only factors for 2 are 1 times 2. That's it. There's no other combination of numbers that I can use from that list that when I multiply them together, I get 2. That's why this is a prime number. So the only factors are 1 and itself. So now that we have that all set, what I'm going to do is I'm going to write down the prime numbers. So let's just have a list, and it's good to have this as a reference. So when you're trying to do something like, for example, prime factorization, it helps to have a list that you can look at. So the list of numbers would be 2, 3, 5, 7, 11, 13, 17. Let me continue over here. 19, 23, and 29. So I'll stop there. But basically, any of these numbers here in this list will not have other factors besides 1 in itself. Right? So when we look at that list of natural numbers, like starting 1, 2, 3, 4, 5, so on and so forth, there's no other combination of numbers when you multiply them together besides 1 and 17 that'll work. Same thing for this one. The only factors are 1 and 13. The only factors for this are 1 and 11. So that's true for any of these numbers. But the moment you put in a number like 24, that will not be a prime number because you could multiply 1 times 24, 2 times 12, 4 times 6, 8 times 3. So composite numbers, you can see they have more than one set of numbers or set of factors that when you multiply them together, you get 24. So again, have this as a reference, and this will help you when you have to do stuff like prime factorization. Let's look at an example of how do we use the prime factors, those prime numbers, to come up with the prime factorization of 12. And you might want to keep that list handy of the prime numbers, right? These aren't all the prime numbers, but this is the first set of prime numbers up to the number 30 so far. But I use this, and that's going to help me figure out the prime factorization of 12. And what I'm going to do is I'm going to make a prime factorization tree. I like to use this setup. You don't have to, but what you do is you make 2 branches, and you say, okay, what numbers what prime numbers, so what numbers in this list can I use to multiply to give me 12? And since this is an even number, I know every single even number is divisible by 2. So this, I can write it as 2 times 6, right? 2 times 6 is 12. So these 2 numbers always multiply to give you back the 12. That's why we connect them. And what you do now is once you have your 2 numbers, is you circle the one that's a prime number. And in this case, 2 is a prime number, right? That's in my list of prime numbers. So I circle the 2. I don't circle the 6 because 6 is not a prime number. It's not in that list. For the number that's not a prime number, you're going to break that number down again. So find factors that are prime numbers. So if any of these factors that are prime numbers that multiply to give me 6. And again, this is an even number, so I know actually 2 could go into that. So this is going to be the same thing as 2 times 3. And now looking at your 2 numbers, which ones are prime? And in this case, you'll see that 2 and 3 are actually both prime. So I'm going to circle the 2 and circle the 3. And now there's no other numbers to break down anymore. So we're going to stop here. So the prime factorization is 12 is equal to, and the numbers you circled, 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So multiply these prime numbers together, you get back 12. So if you look at what we're doing, prime factorization, we're using factors that are prime numbers. So these factors that are prime numbers, only up here, right? These are only prime numbers, and when you multiply them, you get back 12. So if any of these numbers in your list are not prime, then it's gonna be marked incorrect. So make sure your prime factors are only prime numbers. Here's another example. So write the prime factorization of 15. And the same thing, I recommend having your list handy on the side somewhere. Look at your prime numbers so you can use that as a reference. So we're doing prime factorization of 15. So I'll write my 15, make my 2 branches, and I ask myself, which prime numbers multiply to give me 15? So I know that if the number ends in a 5, like this one here, I know it's divisible by the number 5. So 15 is the same thing as 5 times 3. And now I circled the prime numbers, and actually in this case, 3 and 5 are actually both prime numbers, so I'm actually going to circle both of these here. And now you can see that there's nothing else to break down, right? These are our only 2 numbers we need. So 15, the prime factorization of 15 is the same thing as 3 times 5. I usually just write it in the order of smallest to biggest, but it doesn't matter which way you write it out. 3 times 5, 5 times 3 is the same thing, but I just prefer to write it smaller to bigger. But again, this is what we call prime factorization. The factors over here are only prime numbers. When you multiply 3 times 5, you get back 15. And here's our final example, number 48. So prime factorization of the number 48. And notice, in this example here, 48 is divisible by 2 because it's an even number. Anytime it ends with a 0, 2, 4, 6, or 8, we know we could divide it by 2. So I'm going to use 2 because 2 is a prime number. So 2 times, in this case, 24. These two multiply together, give me back 48. So now I'm going to circle the prime number, which is 2. 24 is not prime, it's an even number. And all even numbers, I know I could divide it by 2. And 2 is a prime number, but this will be 2 times 12. So 2 is a prime number. So again, any of the numbers from this list that come up here, you all circle those. The one that's not a prime number, you're going to have to keep breaking that number down into factors that are prime numbers. So 12 breaks down to the number, again, it's an even, so I could divide it by 2. 2 times 6. And then I'm going to circle the 2 because I know that's prime. 6 is not prime, right? That's not in the list of prime numbers. So I'm actually going to split that up one more time. And this breaks down to, it's an even number, divided by 2. 2 times 3 is 6. And I know 2 is a prime number. And 3 is also a prime number, so I'm going to circle that. And since there's nothing else, no factors left that are composite, I could just leave it like that. Now what I got to do is just write down the number 48. The prime factorization, I'm just going to reorganize it. So look at all the numbers that are circled. We have a 2, 2, 2, 2, and a 3. So we have 2. We have 4 of those 2's times 3. 1, 2, 3, 4 2's and 1 3. 1, 2, 3, 4. Yep. So, and you could double check your work by multiplying all these prime numbers together. When you multiply all the prime numbers together, you should get back 48. And if you didn't, you got to go back and check your work. And one little last tip is basically, if you notice your prime factorization has a lot of repeats, like in this case we have 4 2's repeated, you can write it in exponential form. So whenever you have repeated multiplication, you take down the number that's being repeated and you write the number of times it repeats, that's your exponent. So it repeats 4 times. So 2 to the 4th, when you see something like this actually means the same thing as 2 times 2 times 2 times 2. So we're just condensing it, making it smaller. It's kind of like when you like text message, right? If you write down the word like LOL, it's just a condensed form of saying, rather than typing out the whole thing, laugh out loud, we write down LOL just for shorthand. Same idea in mathematics. We like to condense things, make it shorter if we can. So that's, if you have repeated multiplication, you shorten it by putting the number that's being repeated, and then the exponent is how many times that repeats. So 2 to the 4th times 3 is equal to 48. That's the same thing as writing it out this way.